Hello and welcome. In this video, we'll walk you through the process of creating persistent volumes (PVs) and persistent volume claims (PVCs) on Kubernetes using Utho Cloud. Let's dive right in. Persistent volumes are storage resources in Kubernetes, while persistent volume claims are requests for storage by users or applications. Together, they allow applications to store data beyond the lifecycle of a pod. Before we start creating PVs and PVCs, ensure you have a Kubernetes cluster up and running on Utho Cloud. If you haven't already, sign in to your Utho Cloud account, create your cluster, and make sure you have Kubectl configured properly. Now let's begin with persistent volumes. In your Kubernetes environment, PVs represent actual storage devices or disks, and they must be created before any PVCs can be claimed. We'll create a PV using a YAML file specifying details such as storage capacity, access modes, and the storage class. Here's an example of a PV YAML file. In this file, you define the type of storage, whether it's block storage or file storage, along with the storage size and access modes like read-write once or read-write many. Once you've created your PV definition, apply the YAML file using the Kubectl apply fpv.yaml command to create the persistent volume. This will tell Kubernetes that this storage is available for use. Next, let's move on to persistent volume claims. PVCs are requests for storage that can be matched to available PVs. PVCs are often used by applications to claim storage dynamically or statically based on the requirements. Here's an example PVC YAML. In this file, you define the requested storage size, access modes, and storage class. It's important to note that the PVC needs to match the attributes of an available PV for binding to happen. Once you've prepared the PVC YAML file, use the Kubectl apply fpvc.yaml command to create the persistent volume claim. Kubernetes will automatically bind the PVC to a suitable PV that satisfies the request. At this point, your application can now use the claimed storage for its data. This means that even if your pods are rescheduled to different nodes, the data will persist. PVCs help decouple the storage management from the pods, offering flexibility and reliability. Lastly, don't forget to monitor the health of your PVs and PVCs. You can do this using Kubectl get PV and Kubectl get PVC commands to check their status, ensuring everything is running smoothly and your applications have access to the storage they need. And that's it. You've successfully created both a persistent volume and a persistent volume claim on Kubernetes using Utho Cloud. This gives your applications reliable storage that persists even when pods are restarted or rescheduled. Thanks for watching, and happy Kubernetes managing.